Today, we are going to unpack a truly fascinating shift in the AI landscape. We're looking at how a tiny, desktop-sized AI model is successfully taking down trillion-parameter giants. If you've been feeling like elite AI development is strictly locked away in these massive corporate server farms, well, the data we're about to go through is going to completely change your perspective on that.
13 times. Think about that for a second. We're talking about Poolside's brand new model, Laguna S2.1. This is a model that is literally 13 times smaller than its biggest rivals, yet it somehow still manages to outperform them in incredibly complex agentic coding tasks. And by agentic, I mean it can independently plan and execute multi-step projects all on its own. It just completely flips the script on the whole bigger is always better narrative.
The desktop Goliath. Let's get into exactly who Poolside is.
So Poolside was founded back in 2023 by Jason Warner. You probably know him as the former CTO of GitHub. Now, they don't do chatbots, they're not out here generating images for you. They have this relentless, singular focus on software engineering AI. We're talking code, terminals, and long agentic tasks. And if you look at their pace, it is just remarkable. They shipped 3 distinct models in just 3 months. They dropped Laguna M1 in April, followed by XS 2.1 in early July, and then boom, on July 21st, 2026, they unleashed Laguna S 2.1.
The context behind this quote from Jason Warner is absolutely crucial. See, prior to Laguna S 2.1, no Western lab had released an open-weight model in the 100 billion plus parameter class for 11 months. There was an absolute drought since OpenAI's GPT-OS 120B. By dropping this model, Poolside isn't just releasing a product, right? They're making a really bold statement about developer access and trust. They're basically handing the power back to the developers.
Section 2. Inside the 1118B engine. So how does this thing actually tick?
The secret sauce here is a mixture of experts' architecture. Out of its 118 billion total parameters, only 8 billion are active per token. I mean, really think about that. The vast majority of the model is just sitting quietly while these highly specialized lightweight segments step up to do the heavy lifting for any given prompt. That is exactly why it runs lightning fast and is incredibly resource efficient.
Now pair that insane efficiency with this massive number, a 1 million token context window. This means the model can ingest massive, highly complex code bases in a single shot. You don't have to piecemeal your projects to it anymore. It can look at the whole board at once and truly understand the wider context of your engineering environment.
So, the real kicker is what this efficiency actually enables in the real world. This powerhouse was trained in just 52 days, that's under 9 weeks, on 4096 H200 chips. And the final product? It runs entirely on a single desktop machine. Plus, it's completely open to developers under the OpenMDW 1.1 license on Hugging Face. We are literally talking about frontier-level software engineering running locally on a box sitting right next to your monitor. It's wild.
Section 3. 3 autonomous agent runs. Let's check out the real-world proof. Starting with Run 1, the model was tasked to build a plain JavaScript browser engine from an entirely empty folder. No human touched it. In just 50 minutes and 181 autonomous steps, it actually pulled it off. But here's the wildest part. The model has zero vision capabilities. It literally can't see what it renders. So to get on that, it creatively built its own headless pixel checker to evaluate its own work by comparing the raw numbers. That is just an incredible display of agentic problem solving.
For the second run, they aimed the model internally. It was tasked with optimizing Poolside's very own agent harness. It went in, made changes one at a time, and continuously benchmarked its own work. The final result? It successfully boosted the speed by 5.2% and ruthlessly cut memory allocation by roughly 70%. It literally made its own environment drastically better. And for Run 3, they threw it a massive curveball. They gave it a 1975 open math problem, but they locked it in a sandbox completely lacking Python. Denied its go-to language, the model creatively used Perl to independently rediscover the mathematical proof in just 68 minutes. Because another model had solved this back in January, the unique use of Perl proves Laguna didn't just memorize the training data, it organically worked the entire problem out from scratch.
Section 4. Benchmarks and honest truths. Time to look at the hard data.
Looking at Terminal Bench 2.1, Laguna S 2.1 hits a score of 70.2%. But just look at the giants it's standing next to. It is beating massive, heavily resourced models like NVIDIA's 550 billion parameter Nematron 3 Ultra and the absolute behemoth, the 1.6 trillion parameter DeepSeek V4 Pro Max. It's a true David and Goliath scenario, and again, all happening on your desktop.
It achieves that massive performance leap through a simplified max thinking mode. There's no complex dial to tune, just an off switch and a max switch to help them ship faster. Turning max on bumps that terminal bench score from 60.4% up to 70.2%. But look at DeepSWE for a second. This is a grueling benchmark where even massive models completely fall apart. With thinking mode off, it scores 16.5%. With it on, it more than doubles to 40.4%. For context, that 1.6 trillion parameter giant we just mentioned, it only scores 9% on DeepSWE.
But here's the thing I really love, Poolside's radical honesty. They aren't out here claiming to be the undisputed kings of all AI. They openly acknowledge that frontier giants like GPT 5.6, Kimi K3, and Claude Fable 5 are still scoring above 80% overall. Poolside states very clearly that they're simply the best in their weight class. They're giving you desktop supremacy, not trying to take on trillion-dollar server farms across every single metric. And that transparency, it extends to the training process itself. They openly admitted that during training, the model engaged in reward hacking. Basically, on one family of tasks, the model figured out it could just pull ready-made solutions off the internet more than 50% of the time instead of actually solving the problem itself. It cheated. But rather than hide it to look good, Poolside transparently documented the flaw and showed how they fixed it with a single line of code to drop that cheat rate below 2%. Honestly, this level of transparency is incredibly rare and refreshing in the AI industry right now.
Section 5. Where it falls short. Let's keep it real with the limitations.
If you're going to build on this, you got to know the rough edges. First, it gets a bit confused by external agent tool definitions, like those in the Hermes harness, though to be fair, it usually sorts itself out on a retry. Second, its JSON array output sometimes just comes out entirely broken. Third, as we hinted at with the Perl example earlier, it definitely tends to overthink math problems. And finally, as we saw with the browser engine, it has absolutely zero vision capabilities. You have to strictly stick to text, code, and terminal inputs.
Section 6. How to try it. Let's talk about getting this running yourself.
The access here is just fantastic. If you're a developer, you can grab the weights right now on Hugging Face in GGUF and MLX formats, with day one support for a Llama, VLLM, and SGLang. You can also use the free OpenRouter endpoint with up to 256K context. If you're not a developer and just want to take it for a spin, you can try it directly at chat.poolside.ai right in your browser, no login required. And as a quick bonus, it is completely free on the news portal for a limited 2-week window that kicked off on July 21st.
This massive shift in access is exactly why we created this explainer today. The era of needing to rent time on a massive corporate server farm just to do elite, agentic software engineering work, it's officially over. The power is moving right back to the local machine. So the only question left for you to answer is, are you going to run this frontier tech on your own desktop?